Southwest Kansas just recorded one of its most alarming groundwater declines ever measured. In 1 year alone, water levels in parts of the Ogallala Aquifer fell by nearly 1.5 feet, the steepest annual drop on record for that region. But that number is only the surface of a much larger story. In parts of western Kansas, more than 80% of the original groundwater has already disappeared, and the water being pumped out today won't be naturally replaced for hundreds, perhaps even thousands, of years. So here's the question few Americans are asking. What happens when the underground reservoir that helped feed an entire nation begins to run out? To understand why scientists are sounding the alarm, you have to stop thinking about lakes and rivers. This crisis isn't happening where you can see it. It's unfolding beneath your feet. Hidden below the Great Plains lies the Ogallala Aquifer, one of the largest underground freshwater reserves on Earth. Stretching beneath 8 states from South Dakota all the way to Texas, it transformed dry prairie into one of the most productive farming regions in the world. In Kansas alone, this underground reservoir supplies the vast majority of the water used for irrigation, helping produce the wheat, corn, cattle feed, and other crops that fill grocery stores across America. For decades, it seemed limitless. Farmers drilled wells. Crops expanded. Entire communities grew around the belief that there would always be enough water beneath the ground. But nature was keeping a very different set of books. Every year, rain slowly filters through layers of soil and rock, recharging the aquifer. The problem is that this natural process happens incredibly slowly. In many parts of western Kansas, water is being pumped out many times faster than nature can replace it. It's like withdrawing money from a savings account that earns almost no interest. For a while, the balance still looks healthy. Then one day, the account starts disappearing faster than anyone expected. That is exactly what groundwater scientists are now measuring. Each winter, teams from the Kansas Geological Survey and the Kansas Division of Water Resources travel across western Kansas, checking hundreds of monitoring wells by hand. They lower measuring tapes deep underground, recording exactly how far the water table has fallen since the previous year. The latest measurements revealed something deeply concerning. Southwest Kansas experienced its sharpest annual groundwater decline on record. In neighboring counties, the long-term trend continues to point in only one direction down, and some places are already living in the future that other regions hope to avoid. Near the Colorado border, parts of Wallace County have already lost more than 80% of their original groundwater reserves. Some monitoring locations have experienced water level declines measured in several feet within a single year. This isn't simply another drought. Droughts eventually end. Ancient groundwater depletion doesn't. That's because much of the water stored inside the Ogallala Aquifer isn't modern rainwater. Much of it entered the ground thousands of years ago. During cooler and wetter climates, long before tractors, irrigation systems, or even modern civilization existed across the Great Plains. Once it's pumped away, it cannot simply return after one rainy season. Scientists estimate that fully recharging heavily depleted portions of the aquifer could take centuries, and in some areas, well over 1,000 years. The water leaving today is effectively gone for generations. And here's where the story becomes even more serious. Nearly 90% of the groundwater pumped from the Ogallala is used for agriculture. Kansas alone withdraws billions of gallons of groundwater every single day to irrigate crops growing in a naturally semi-arid landscape. Without irrigation, much of western Kansas simply couldn't produce crops at today's scale. That means this isn't only a water story. It's a food story, an economic story, and increasingly a national security story. Because the Ogallala Aquifer supports a significant share of America's wheat, corn, beef, and other agricultural production. Every foot the water table drops makes farming more expensive. Wells must reach deeper. Pumps consume more energy. Some wells eventually stop producing enough water to justify planting irrigated crops at all. And once enough farms reach that point, the consequences don't stay inside Kansas. They begin spreading across the country. So how did one of the largest underground freshwater reserves in the world reach this point? The answer wasn't hidden beneath the ground. It happened above it. For generations, western Kansas became an agricultural powerhouse because of irrigation. Powerful pumps turned dry grasslands into endless circles of green corn, wheat, sorghum, and alfalfa. What was once considered marginal farmland suddenly became one of the most productive agricultural regions in America. The system worked so well that almost no one questioned whether the water below could actually last. Scientists now say that assumption may have been the greatest mistake of all. Unlike a river that flows every year or a reservoir that fills after heavy rain, the Ogallala Aquifer behaves more like an ancient savings account. Most of its water accumulated over thousands of years, yet modern agriculture has withdrawn enormous amounts in only a few decades. In some parts of western Kansas, groundwater is being pumped many times faster than nature can replace it. That imbalance has been growing year after year, and eventually, every underground reservoir reaches a tipping point. The first warning often comes quietly. A farmer notices that an irrigation well isn't producing as much water as it once did. The pump runs longer. Electricity costs rise, the growing season becomes harder to manage. Then another well slows. Then another. Eventually, some wells stop producing enough water to irrigate an entire field. What once seemed like an endless supply begins disappearing one farm at a time. But the crisis doesn't stop at the edge of a field. Western Kansas is home to some of America's largest cattle feedlots and grain operations. Those industries depend on enormous harvests of irrigated crops. Less groundwater means fewer irrigated acres. Fewer irrigated acres mean less feed. And less feed affects everything from beef production to grain markets across the country. The chain reaction begins underground, but doesn't stay there. It reaches grocery stores, food prices, rural jobs, entire communities. Some towns across western Kansas were built around agriculture. Local equipment dealers, trucking companies, grain elevators, feed mills, and family-owned businesses all depend on successful harvests. If irrigation declines year after year, the economic pressure spreads far beyond individual farms. That's why researchers aren't describing this as simply an environmental issue. They see it as a long-term economic challenge. And perhaps the most troubling part is that scientists already know what needs to happen. Reduce groundwater pumping. Increase water conservation. Use more efficient irrigation technologies. Grow crops that require less water. Several farming communities have already taken voluntary steps to reduce groundwater use, proving that conservation can slow depletion. But slowing depletion is not the same as reversing it. Even if pumping stopped tomorrow, much of the lost groundwater would not return within any human lifetime. In some places, the underground layers that once stored water have begun to compact as water is removed. When those tiny spaces collapse, the aquifer permanently loses part of its storage capacity. In other words, the underground tank doesn't simply empty, it slowly shrinks. That's why groundwater experts often describe parts of the Ogallala as a non-renewable resource on human timescales. Every gallon pumped today represents water that future generations may never have access to. And the numbers continue moving in the wrong direction. Across Kansas, long-term monitoring shows decades of steady groundwater decline. In several western counties, more than half of the original groundwater has already disappeared. In the hardest-hit areas, losses exceed 80%. Every winter, scientists return to hundreds of monitoring wells. Every winter, they collect new measurements, and too often, the pattern remains the same, lower than last year. The greatest challenge isn't that researchers don't understand the problem. It's that solving it requires difficult choices. Less pumping today means protecting water for tomorrow, but it also means changing farming practices that have supported local economies for generations. Communities now face a difficult balance between preserving today's harvests and protecting tomorrow's water supply. Because once the aquifer reaches a certain point, there may be no practical way back. Stand in western Kansas today, and nothing immediately looks wrong. Fields still stretch to the horizon. Center pivot sprinklers continue turning. Harvest trucks still roll down country roads. Life appears normal. But beneath those fields, the water table continues falling, foot by foot, year after year. Silently, the Ogallala Aquifer helped transform the American Great Plains into one of the world's greatest agricultural regions. The question scientists are asking now is no longer whether the groundwater is declining. That has already been measured. The real question is whether the remaining water can be managed before more communities reach the point where the wells can no longer support the farms built above them. Because the greatest threat isn't a sudden disaster, It's a slow one, a crisis measured not by floods or storms, but by the quiet disappearance of water that took thousands of years to collect. And once it's gone, America's breadbasket may never be the same again.